Now, graphing is not usually the best way to solve a system because, again, it's inexact. It gives us a rough ballpark unless we have very precise instrumentation. So we have another avenue to solve a system, and it's called a technique called substitution, or solving a system by substitution. And here's a system. Notice that they're both lines. The first one happens to be written in slope-intercept form. The second one is in standard form. Doesn't matter. They both represent an equation or a linear equation. So how we use substitution is first of all, we solve one of the equations, well, not solve, or rewrite one of the equations in terms of a variable. So we solve for an x or solve for a y. Now notice this particular example, the first one, I already solved it for y. So how does substitution work? Well, substitution takes what we solved for a variable and substitute it into the variable in the other line. So I'm going to take the second line, which is a 4x minus 3y equals 24. Then I'm going to take this y and substitute it in there. So I will have now a 4x minus 3 times a y, which is this entire substitution up here, because y equals negative x minus 1. You see that? That value right there is equivalent to y. So when I see a y, I can just substitute that value in there. So I have 4x minus 3y equals 24. Notice what's happened now. I began with a system with two unknowns, and now I have a system, it's a system still, with one unknown, and I can solve for this particular variable. So let's clean it up. Am I doing all right? And what do you see x equaling? Divide both by 7. X equals a 3. There I have. Have I solved the system? No, haven't solved the system, but I found out where if the system has a solution, their x's match up at 3. So how do I find the y? Well, I take this value and I put it back into the other equation. So I'm going to take that value and stick it into that other equation. So it becomes y equals minus x minus 1. I'll take this 3 and put that 3 in there because I want to find out what's the y when x is 3. Solving this out, y equals minus 3 plus a negative 1 gives me a negative 4. So the solution to my system then is at the point 3, negative 4. And I could check that by plugging them both in, finding out that they're true statements. So what do you think? You like this idea about substituting? I kind of do. Now, not all the time are the systems going to be so readily available to substitute. Sometimes we got to do a little bit of work first. The work I'm doing is I know I want to solve one of these equations for x or a y. So I'm going to look to find out where's the easiest way to do that. You can do it harder if you want. I'm going to look for the easier way. And I see this x all kind of by itself. There's no coefficient. All I have to do is add 2y to both sides. X is by itself. But I want to help you develop a pattern of how we're going to do that. I want us to keep in mind that we're solving the entire system. So what I'm going to do is I'm going to rewrite the system again with one modification. The first line I'm not doing anything to. The second line, I'm going to add 2y to both sides. So then I'm going to get an x equals a 2y minus a 3. Basically what I did is I have the same or an equivalent system. Both of these are equivalent. All I did is just added 2y to both sides. But I wrote the entire system down because I think that's going to be a pattern that's going to be helpful for me to get used to. So what do you want to do now? Yeah, I think we're ready just to frankly substitute very clearly. This x is a 2y minus 3. Let's put all of that in for the x in the first equation right there. So I'm going to write it as 5 parentheses because I'm going to add this entire 2y minus 3. Since that's substituting for y, I need to make sure I have a parenthesis around it. So this 5, because the 5 is being multiplied to the entire value. So I have 5x minus 4y equals 9. From there, let's just root it out. 10y minus 15 minus 4y equals a 9. 15 plus a 9 is a 24. Then y equals a 3. Now you remember, you're right, we're not at a solution yet, but we're almost there because we found out what the y is between the two. Now let's take this value of y and we can plug it into the system that we started with. So let's take it up here, plug it into one of those values that we solve, that we see, either one, doesn't matter, and solve for x. So let's look at this one right here. X minus 2y equals negative 3. X minus 2. The y we discovered was a 3. Make sure I wrote down the equation right. Yep. And then x minus 6 equals negative 3. Add x to or 6 to both sides and gives me a 3. So I have a solution for this particular point right here. Both of those threes, did I make a mistake somewhere? They can be. Oh, yeah, duh. 6y equals 24. I got y equals 3. No. Divide both by 6. I get a y equals a 4. Thought something wasn't quite sitting right with me. All right, let's take the correct value of y this time and put it into those equations. So scratch that. Start again. X minus 2y equals minus 3. Put in a 4 this time because that's the correct answer, or the correct value of y. Add 8 to both sides, and I get x equals 5. Kind of shakes your confidence a little bit when you do something wrong and you catch it and you're like, all right, you're second guessing yourself all the time. So the solution I have then is the solution 5 and 4. So the point 5 and 4, we can check that to see if that's true in both those lines. So 25 minus 16 equals 9. And then 5 minus 8 equals a negative 3. So it works in both of those equations, part of that system. So this is the solution to that system.